Okay. So first student work sample, to increase morale among employees. A company began a program in which one employee is randomly selected each week to receive a gift card. Each of the company's 200 employees is equally likely to be selected each week. The same employee could be selected more than once. Each week's selection is independent from every other week. So for part A, which was the entire front side, they wanted us to consider the probability that a particular employee receives at least one gift card in a 52-week year. Define the random variable of interest and state how the random variable is distributed. What do you guys think about this first part? Do you think that would be a significant answer to it? They did not fully identify the random variable. What is our random variable here? Maybe the 200 employees is a pick for the gift card. Each week's selection is independent from every other week. So we want to consider the probability that an employee receives at least one gift card. How many employees are we looking at here? Just looking at one. There's 200 employees of the whole company, but in part A, we're considering the probability that a particular employee. So we're looking at just one person right here in part A. We want to determine whether or not they received at least one gift card. Is it possible to get more than one at this company? Yeah, not the same week. Every week, one person is drawn. But because it's supposed to be a random drawing, you could potentially get lucky and win the second week as well, right? Says is distributed by random. What do you guys think of that as far as describing the distribution? Now, thinking about this in terms of one person and whether or not they win a gift card, how would this be distributed? Binomial. We might be able to approximate it with a normal, but it would be distributed binomially. How would we know that it's distributed binomially? Like, what could we do to show that it definitely is binomial? In binary, what would be the success? Getting the gift card. All right. Independent, they told us right here, we're assuming it's independent. So we're given that piece. Number of trials. 52. So each week you can come up for winning that. And then probability of success. 0.005 or 1 out of 200, right? Yes. So showing that would be, instead of saying is distributed by random, binomial distribution, go through your bin so that you can actually state that yes, this is a binomial distribution. Random variable of interest would be not just an employee receives a gift card, but we're looking for how many gift cards a particular employee receives in a 52-week year, not just overall for all time. Determine the probability that a particular employee receives at least one gift card in a 52-week year. What do you think of their answer? Is that the same thing as what you got? Is this a correct idea? Ooh. I know the word now. I'll put it up. Probability of at least one gift card means that gonna be, anytime we're looking at probabilities, it's 1 minus the probability you didn't get A, right? Now, that doesn't help me find the probability that they got exactly 1 gift card, or that they got exactly 2, or that they got exactly 3, but the probability that they did not get a gift card, there's only one way that happens. Every single week, you do not come up for 1. Does that clearly describe it as binomial? Not really. Not really. They did get the right. It's within 1 decimal point of the correct answer here. So they got partially correct here on part A. So they did come up with the correct value. Go ahead and flip over and look at the back side for this particular individual. Expected value. Calculate and interpret the expected value for the number of gift cards a particular employee will receive in a 52-week year. Did they come up with the correct value? N times P would be how you find your expected value or your mean. Did they provide any interpretation or context of that? No. Did they have any interpretation or context on the first part either? No, you want to make sure to interpret and provide context on what your values are being considered. Oh, it's 0.26. They just multiplied those two together. I think they were just going really fast. Or depending on kind of the student's mathematical background, students that have been taught overseas sometimes would have comments of the decimal points. Because they tend to reverse that notation. I'm thinking specifically in Europe, although I'm sure some African nations do the same thing. I'm not sure about Asian countries. I just know that typically that tends to be. Oh yeah, no, it's just think of it as 0.26. Go down and look at the last part here. So far they've gotten 2 partially correct. The last one they got the correct value, but they provided no interpretation, no context. It was just a number at the end. So not really sure that they know what that number means. One of the things, I don't know if you guys have noticed, but on the AP Stats test, a lot of times they are not saying things like explain and make sure to provide context. It's understood that you need to be explaining and providing context on any problems where you just have a numerical. Part C, suppose that Agatha, an employee at the company, never receives a gift card for the entire 52-week year. Based on her experience, does she have a strong argument that the selection process was not truly random? No. We want to go back and look at the work that was provided back here. Probability of not getting a gift card is quite high. There we go. Since this probability is quite large, Agatha does not have a strong argument that the selection process was not truly random. The probability is correct, stating right here this idea that that is a large probability, so therefore it is most likely happening randomly. She just got unlucky for that entire year. Essentially correct on this part, so they got full credit on part C. The student received a score of 2 overall, because they had 2 partially corrects and 1 essentially correct. They got a score of 2. We'll look at another student's work. Look at the way they define their random variable. The random variable of interest is the number of gift cards received in a 52-week year. It is binomially distributed based on these conditions. Random selection has occurred. Each week's selection is independent. Fixed 200 observation. Probability of success is the same, always equally likely. You either win it or you don't. 1 outcome out of 2. They didn't write bins, but did they hit all of the ideas from this? How do you guys feel about this first part, part A? I think they nailed it. Probability that X is greater than or equal to 1, that would be at least 1 gift card, would be 1 minus the probability of not getting any. The probability that X is 0. And then they use their binomial distribution here, 1 minus 52 over 0, or this would be 52C0. We have observed 0 wins. This is another way of writing it without the C, but I'm used to writing it with the C. Here's the probability of success. We had 0 observations of that. Here's the probability of failure. We had 52 failures. And they calculated that probability. For 0.22945, this is where I think the other person wrote 0.2294 instead of 0.2295, just a rounding thing. And then they provided some context down here. The probability that a particular employee receives at least 1 gift card in a 52-week year is 0.2294, and then they wrote all the decimals. You do not have to include all the decimals. Usually 4 places is more than 2. How do you guys feel about the bottom part? They nailed it. Part A, they nailed both the first and second pieces of part A. Person before us still would have gotten a partially correct on this part if they had provided the explanation, but they still needed that explanation. That might have been kind of that tipping point between a 3 and a 4, or between a 2 and a 3, sorry. Look at their answer to part B. How do you feel about the answer to part B? Numerically, that they do that correctly. Yes. What do we think of their explanation? Exactly. So not after many, many, many weeks. Says the expected value demonstrates that a particular employee will receive. Do we think that they will receive this? No. You could say that approximately 26% of the, or sorry. Yeah, 26% of all the employees after many, many, many weeks, 26% of all the employees will have received at least 1 gift card. What would you feel about them? Read through what they had and tell me what you think. They show their work to support it. They could have done 1 minus their answer from the front side because that would have resulted in the exact same decimal value here. This would be the probability of never receiving a gift card. For any particular employee, the probability that they never received a gift card in that 52-week period is about 77%. It's very probable, it's highly likely that somebody never receives a gift card. So that means that they are, you know, this is not a very rare event. Essentially correct on this one. The person received a score of 3 out of 4. Let's go look at, it's not a perfect paper, but they received a 4 out of 4. So they received an essentially correct on all 3 parts. Let's go look at that model answer there. Define the random variable. X equals the number of gift cards an employee receives. The random variable is binomial. If the probability of success equals 0.005 and n 52. Binary, receives or doesn't receive. I, each week's selection is independent from every other week. N, fixed number 52. S, set probability 0.005. They nailed that section. It showed that it was binomial by meeting all of the qualifications. And they correctly identified our variable. Instead of writing, yeah, you can write bins, and then I would still say, like, you have to explain what bins means. So stating that the variable is binomial, and then if you had all of this right here, that would be sufficient. You don't have to write a full paragraph, no. They did want the random variable defined, so that would have to be a separate thing as well. Down below, they clearly showed that it was binomial, probability of 1 minus less than or equal to 0, so 1 minus, and then they have their binomial distribution. You can use binomial CDF on this. You do not have to calculate it by hand. So you could do 1 minus your binomial CDF, just when you write inside the parentheses, and you put the numbers in there that you type into your calculator, you need to state what those things are. This is N, this is P, this is the X value that I'm interested in. So inside your parentheses, you need to label those. And tomorrow, when we're going over the test review, I can show you exactly what I mean by that. But looking at the scoring guide, you do not have to write this out, but you do have to explain, if you're using a calculator, what all the parts mean that you're typing. They know whether it's a difference. And then they did explain what this meant here. This is the probability of receiving at least 1 gift card in a 52-week year. So they didn't write this beautiful long paragraph or sentence, but they did explain what that value meant. If you guys need me to go back to this, I'm happy to go back. Just let me know. There we go. So they found the same expected value as the other 2 students, and then they explain it if many random samples of 52-week years are chosen, then there would be an approximate average of 0.26 gift cards a particular employee will receive. So we're looking at a 52-week year. So our N is 52. That's what we used up here to find the expected value. So we have many years that we're looking at. There will approximately be an average of 0.26 gift cards for a particular employee. It wouldn't be sufficient to just look at 1 year. That would just be 1 trial. Or one random sample, sorry. One trial. And then down below, again, this individual recalculated, not receiving any gift cards at all. So they redid some of their calculations from earlier. Again, you can use that binomial function on your calculator as long as you explain the value that you're typing in. Absolutely. I think that would strengthen your answer. Absolutely. So what you want to say in there is like, this is happening more often than 5% of the time. So this is not statistically significant. It's happening far too often to be explained by anything other than most likely just random. So they don't have a strong argument that the selection process is not truly random. Did going over the 3 student examples and going through this yourself can help you guys understand this type of question better. One of the pieces of feedback that I've seen happen a lot is that there is always a binomial question at least one place, sometimes more than one place on the exam. And the binomial questions tend to be routinely missed because students misunderstand that they're looking at a binomial situation. So we're making it more complicated than it needs to be. So always be looking for that yes, no, success, fail. If you see until success, that's going to be geometric. But if you're looking at a number of successes versus a number of failures, then that's a binomial situation. I wanted to give you guys the last little bit of time to work on your reviews, or if you wanted to continue to work on the multiple choice from today, you are more than welcome to do so.